So in this video, I'm going to be showing you how to implement a simple parallel circuit, alright, from the schematic to the breadboard. Okay, so I have already placed the 9-volt battery plus the R1 and R2, and we're going to connect up both R1 and R2 in parallel. Okay, so let me go ahead and do that. Okay, so that is the first wire. Alright, and then the second wire for the resistor. Okay, so basically what do we have? We have a 9-volt battery connected to R1 and R2 in parallel. Okay, now why do we say they are parallel? Because the current that comes out of the supply, when it reaches this node over here, it will split. Okay, some current will go into R1, some will go into R2. So whenever there is a split in the current, then we say that those components are in parallel. Okay, if the same current flows through the components as we saw in the earlier video, then we say that they are in series. Okay, so now we are saying that since the current is splitting into R1 and R2, we say that they are parallel. Alright, so now how do we go ahead to implement this on the breadboard? Okay, so I have the power supply already connected up, alright, same as in the earlier video. The plus 9 volts is connected to the top row and the negative is connected to the bottom row. Okay, so let's place my resistor. So I'm going to place the first resistor here. Okay, so this is your R1. Alright, and as before, I'm going to connect, okay, from a wire, okay, or connect the terminal, one of the legs of R1 to the top row over here, the plus row. So it is connected directly to the plus of the 9 volts. Alright, and what I can do is, okay, I can move this resistor slightly here. Alright, and what I'm going to do is I'm going to connect this to the bottom terminal here. Alright, so what is happening? Alright, so this R1, the current that comes out of the terminal here will go into this row, flow through R1 and go through R1, and from the other leg go to the negative and come back. Okay, similar to what we see here. Okay, but now we want to add R2. Okay, and R2, the legs are connected to the same points as R1. Okay, so R2 I'm going to connect. Okay, and I'm going to do the same thing. Okay, where I'm going to connect this leg to the top row and the other leg to the bottom row. Alright, so this is how you can connect both R1 and R2 in parallel. Okay, in parallel to the power supply. Okay, so this, what you're seeing here is exactly what we have over here. Alright, now of course you can say, what if my resistor legs are not long enough? Alright, and you have a bigger breadboard and so on, then you can always use jumper wires to extend. Okay, so let me show you. So for example here I can connect, okay, from here to here. Alright, so I'm connecting the resistor across the gap. Alright, so on the same column, column 10 and column 15, alright, so one leg goes to the upper half, the other leg goes to the bottom half. Alright, and then, okay, and from that same column I connect a wire to the top row and another wire to the bottom row. Okay, I do the same thing for the other resistor. Okay, and this is the same as before. Okay, so this is how you can go ahead if your resistor legs are not long enough to stretch the entire length, alright, or breadth of the breadboard. Alright, you can go ahead to put it just across the center gap and then use additional jumper wires to complete the circuit. Alright, so this is how you can design a simple parallel circuit, okay, from the schematic all the way to the breadboard. Okay, so thank you for watching, and I'll see you in my next video. Bye.